Alright, in this video we'll take a look at the primitive data types that are available and most commonly used within Unity. These are C# data types. So I'll jump in and open up the Unity program, and I've already downloaded the Unity with Cocktails project, which is explained in a previous video and available on the /Unity link. So within the default layout here, I'm going to rearrange a few things, bringing console over to the side, maybe splitting my game window apart just by dragging that, and then up here saving that layout. I've already saved it as Unity with Cocktails, so I'm going to go ahead and just pop that open and get the default layout I'm going to use for this video series. So navigating within the project window, inside the Unity with Cocktails and Lessons folder, there's a folder specific to each project. Now it's important to note that these videos will be recorded over a period of time, and the source code as well. Here this one project might change, so the exact folder structure you see there may change, but I'll try to be consistent with this naming scheme. So today we're looking at 2.1, which is the primitives. So I'll open up that folder, and within we've got, for this simple project, just one scene, and we've got one C# class. So let's go ahead and take a look at how this project is set up. We'll open up the scene by just double clicking, and inside the hierarchy we see that there's three items in our scene. There's the instructions text, which I'll use from scene to scene to just give you a quick 1, 2, 3 steps of how you're going to be looking at the source code in case you check it out without the video playing. There's the camera, which is common in each scene. The camera position in the scene view, where the white lines here are indicating some portion of the camera, that is what dictates what shows up in the game window here. So the camera is going to be consistent in each scene, always there helping us render. Then a key part of each of these video scenes for the demos is that the manager game object is going to be an empty game object where we've added one class to it. So if I select in the hierarchy manager's game object and look in the inspector window, I see that there's one script attached to it. The way that that's attached is just by selecting any script and dragging it out here into the hierarchy. I'm not going to release the mouse there because it's already been added, but that is how you add. Another way you can add a script is by choosing Add Component and then typing the name of the component in your library, which you can start typing and it auto-completes. But again, I won't complete that step because I've already added it, and in your sample project it would be added for you already. What that means that it's added there, when we run the scene, Unity looks into the hierarchy, and for each game object, including manager's game object, it looks at any of the scripts that are added in the inspector, which we see on the right, and it will begin to execute their code in a very predictable order. And so we'll take a look at that. Now. So let's go ahead and just run, and we see in the console window has output, which this is some simple output that we'll go through step by step, and then I'll stop the video. And that's what the steps in the scene view: 1, press play; 2, view console; 3, press stop. Stop in this case, I'm just clicking the play button again. Here I'll click it on, and then here I click it off. You can see the screen went dark for a bit, and then it comes back indicating we're back into the edit mode. So here that we're sitting into the app, let's take a look inside MonoDevelop. So I'm going to double click the C# class that we're speaking about in this series, and MonoDevelop will open up. So with the Mac here, I'm just using Command and Tab to be able to tab between the two applications. You can also go down to the dock and choose Unity and choose MonoDevelop and choose Unity and choose MonoDevelop, but I use Command Tab, and on your computer, Windows or Mac, you can use that same hotkey or something similar. So let's take a look at what is the class setup here. So you can see I've got quite a bit of comments. I'm using my own best practices, which I explain on my website in a separate post, how I like to comment the code and the naming conventions I like to use. But we won't get into those specifics yet. Let's just start with the very basics here. So there is some importing, which tells this class which references to existing libraries it's able to access. So the two most common ones you'll see is Unity Engine, which lets us take advantage of Unity classes, and then there'll be some other C# libraries too, system collections, etc. I'll note here that Unity is compatible with 3 different coding paradigms. There's BooScript, UnityScript, which is also known as JavaScript, and then the third is C#. The community generally agrees that C# is the most powerful, perhaps the most complicated. So we're going through only C# in the entirety of this course to be consistent and to help us all take advantage of the most powerful of those 3 options. So everything we're looking at here is C#. So beyond the imports, there's the class statement, which tells us that our class is called Lesson 2.1 Primitives, and it's extending a class called MonoBehavior. Then we're going through here. Everything that we see in green is just simple comments. In places in the source code, there's lots of links for you to look at if you want deeper information. The sections are broken apart with some different headers, just comments that I put in to break it apart. All right, so this is the entirety of the class that we're looking at today. All right, so let's step through each one. Okay. So I'm going to use the double slash in front of many of the lines here to comment these out. When you comment out a line, that means that it will not be executed. The compiler, which runs in Unity when you press play, it only looks at the lines that are uncommented, like 9, 124, 125, but it won't look at anything beneath that, 126, 127. Those will be ignored. And we're going to do that just to concentrate what we're looking at here. So I'm making a change, and then each time I make a change, I'm just going to go to save. So I'm covering a few of the basics here, but with the videos as they continue, we'll be taking these steps for granted. So every time I go ahead and save there, now we've made some changes by doing those comments and saved. I'm going to toggle back over into Unity, and here I'm going to press play. So when I press play, in the output window we see some text displayed, and that text is going to correspond directly to debug.log, which is one of the methods that you can call on the existing library within Unity called debug. And what debug.log allows you to do is pass any string you want here. I'm passing a long series of dashes, and then our theme, colon, some space, and then you can see wine. Okay? So how does that happen here? 124, debug.log, within quotes, I just pass a long series of dashes. This is similar to trace inside Flash, or each development environment has something similar to that, but it's really just for debugging. The end user doesn't get to take advantage of any of these debug.log. It's really just for us during development. So let's see. The debug.log for our theme is specified here. The our theme underscore string colon and some spaces are within quotes, so that's literally is going to be passed to the output window. And then plus just means and also send this variable's value, our theme. So within the MonoDevelop, we can right click, and there's a whole host of options, but one that I'll be using quite often is go to declaration. So if I want to see where I declared this, which is just a few lines above us in the page here, I can go to declaration. Our theme is declared here, and it has a value of wine, which corresponds to the output that we saw before. If I select our theme underscore string and I go to find references, that will tell us where did we use this. So find references will bring a list up, and we've got 2 spots. It's used here in this very line, and it's used here in the output debug.log statement. So again, just by using that right-click menu, we can go to where the declaration of a variable is, and we can find any references. This project is relatively simple, but in larger projects you may want to take advantage of those two. Go to declaration and find references to be able to hop around and see where you've utilized different variables. Okay, so the tab here, which indicates which class we're in, I'm going to double click that to go full screen and double click that to go to smaller screen, just so we can take advantage of a little bit more screen room. So I'm going to double click it to go here, and then let's just start at the top of the list here. So the theme for this class is wine. Excuse me. So a lot of the terminology in this particular class file are involving the drink of wine. Other ones might involve beer, and I'm just using that as a loose theme for us to have some consistency to some of our naming schemes. Okay, so what primitive data types are is the most simple raw storage capabilities of a language. So in C#, I've covered a lot of them. Maybe I didn't cover all of them, but I'm just trying to show you the most basic variables that you're going to use. So let's take a look at each one. A lot of these are going to be review depending on what language you're coming from, and very similar. So I'll try not to use my cursor. I'm just going to speak about lines 99 to 104. So we've seen our theme string is wine. The next one is a Boolean, which can hold the value of true or false. You'll note that that true does not have quotes around it because we don't want to pass it the string value of true. We want to pass it a specific keyword called true. So that could also be false. And we'd update that just by changing that there. Very basic stuff. So other types that we've got are the unsigned integer, which is an always positive value with nothing after the decimal point. So 750 could be 4, could be 0, but it could not be -5, -5.5, or 5.5. It can only be positive numbers and without any fractions. Int is a positive or negative without any fractional elements. Float is something more precise. It can be 25, it can be 25.0, it can be 25.4. Something that I found odd when I started learning C# is that when you declare float values, you'll put an F here. And I put a comment here that that F forces a float value instead of double. Okay, the double value, which is the next type we see, may look similar. They both could describe 25.4 if we wanted to. We could update the double to be 25.4. But it's important to note that double requires more memory. Theoretically, your application would maybe be more limited if you used all doubles throughout. So if you don't need the precision of double, and I'm not sure how many decimal points double is, a float is appropriate. So I think between int and float you can accomplish a lot of your numeric needs. Okay, next let's talk about enums. So enums, maybe in another language you were used to using a string for storing the types of things. So perhaps you'd have a string called his drink type, and he likes a drink either cold or hot, right? A problem with that is that it's not strongly typed in that I could pass COLD, COLT, COLE. I could be misspelling that because a string type can accept anything within 2 quotes, right? So we want to be more specific when we're talking about some types, right? So in a use case where you've got a limited number of I want to avoid using the word type. When you have a limited number of things inside of a category, so here we're talking about temperatures, I only want 2, hot and cold, you're able to declare your own custom drink temperature type enum. So if we look up at where I've declared it, actually I'll take advantage of using goToDeclaration, we can see that you declare public enum, give a custom name you like, and then we can give as many different elements within this list as we want. And the drink temperature type can only equal exactly one of those at any given time. So cold, hot, and room temperature, right? So here we can even see, we get some help from the compiler, that when I go to declare this, I type equals, and it's telling me already drink temperature type, and then it knows cold, hot, and room temperature. So anywhere you would have used a string to define a limited set of values, you can think about using enums. Now they're supported in C#. Right? Next is an array. An array is a list of similar elements. Right? So here I've got a favorite red wines array, which is of type string. So the way that you declare arrays, it was quite new for me when I began to learn C#, is that you use the same declaration you would use for a simple string, and then you use the open and close brackets, and that's saying we want to be an array of type string. So here we need to use the similar syntax here, new space, and then we type string in some brackets. But a limitation of the arrays inside of Unity C# is that you need to specify exactly how many elements will be in this array. And you'll find that's a bit frustrating. There's many cases where you want a non-fixed size array, and there are some solutions for that. But for primitive data types, when you want to use an array, you must specify how many. So I want both Malbec and Merlot, so I specify 2. So we were talking about how the arrays are of type string here. If we wanted to declare a different type, let's say int, we could do that simply int open and close my int array. Let's say it was a name I liked, new int, and I would specify I want it to be 2. My int array at index of 0. I give that any value that works with int, and then a second one here. Okay, so that's how we declare, and you can do that with any type. So it's nice. What we know about an array set up in this way is that each value inside that array is going to be of one type exactly, right? So it's going to be string, or it's going to be int, or it could be of a type of your custom classes. And if you need more flexibility, there are solutions, but within the basic array, this is one of the limitations, right? Now, if we wanted to create an anonymous object really quickly and be able to access some of the values, this is what you'd declare. You'd use the var keyword, and then we'd give a name, and then we'd use new, and then use these brackets. This is a little bit, looks hacky, but what we're able to do is just really quickly prototype a variable type of empty bottle of wine. Later we may make this our own class and give it a public property of color and a public property of is flavorful, right? But for here, this is a quick and dirty way to do it. So let's go ahead, and I'm just going to use Control-Z, back up through the project, really just to get to this part. So I'm back to, really have reverted the class back to the way we started, and we'll go ahead and look at the console output again. Okay, and all we're going to see with the console output is that we get each of these variable names is going to be traced out. Next to favorite red wines array, you'll see that we're just going to be giving the 0 index, that first value. And we can also take an entire array and use the toString method, which will return a string for representing the entire array. With the empty bottle of wine anonymous object, we're just able to access any value that we want there. You can see we even get strong typing, which is nice. And the drink type, here we're just testing, is his drink type the same as her drink type. So let's look up here again. Remember, his drink type is going to be cold, her drink type is going to be hot. So if we compared those two, they would not be equal. So that should give us a false on this line. And then we'll come back and look at the reflection setup. All right, and that's it. That's what all these primitive data types are showing. So go back to the project, give it a run. Right. So in the console window here, I'm able to just use the space bar. I'm able to do a single click on console and then hit space bar, and it'll show us that full screen. Space bar again will shrink it. If I click on inspector once and hit space bar, it goes full screen, space bar again goes small. So if I want to take a quick look at all of the console values, I can just jump us in. So I can scroll up and we can step through here. You'll notice that each of the output lines, its second line, reminds us what is the method name we called to make this output happen. So I find it a bit difficult to read because I really only want to see our theme underscore string colon wine. I don't want to see Unity engine.debug.log. There are ways to tweak around that, but this is the default behavior you're going to see in your project, so that's what I want to show you here in the video. So you can see we got wine, true, 750, -10, right? Nothing surprising here. That array to string doesn't give us something very useful, just shows us system, string, open, close, bracket, so it's just showing that it's an array. Right? So there's a way we could tweak what that to string gives us, but let's just use that for now. Red, exactly, right? So let's jump back over here. Take a look at a different type of comment we're able to do. So remember I did // is how we commented out a line before. I can also use /*, go down to where I want to end a block and */, right? Pretty common. Every language has something similar to that, maybe even that exact same syntax. And I'm doing that just so we can concentrate our output here. So again, we're giving the our theme strings value as we did before, and we're taking advantage of some methods here of what's called reflection. So reflection is each of these primitive data types, as well as any data type in C#, is going to be able to return values about itself. So we're able to know that our theme string, we can get the type of it. Now we know just by the naming structure that I've used of underscore string, it's a type of string. But let's take a look at the output that we've got. So I'm going to save, pop over, run the application again, take a look at our console by clicking console and then spacebar. So we can see our theme string is wine. That's the value we'd expect. Its type is system string. The next value is system string as well, then true, then wine. Now let's take a look here and see what that is all about. So when we get the type of our theme string, that's a string. And then if we get type of string, which is type of is another type of, it's another way that is helpful in reflection. Now why would you care? Why would you need to do that? Okay, wouldn't we remember that we've used a string type for this, and why would we ever need to check on that? Well, you'll find in your code you may need to do something like that. And maybe it's a more advanced technique, but you might need to do something somewhere along the line where we're checking to see if the type of a given variable is, in this case, string. So maybe I might need to do a check like that, right? So we don't really have a use case or a need for that now, but I just want to get you thinking that there's data about the variable itself. We're able to get the type of it and quite a bit of other things too. We can get its full class path, its name, and some other data too. Now this check that I've done here is very similar to using the is operator, and the as operator is different. But the is operator is going to say, similar to line 148, is the data type the type of string, right? So what I've highlighted there is shortcut. As is a different case. As is doing something called casting. So it's not checking if something is true or false. It's saying make our theme underscore string behave as a string. We know it already is a string, so to have this variable behave as a string, it doesn't change how it's working. But the as operator, in more advanced techniques, you may need to have a variable behave as a type, something other than it is. So maybe we could have it behave as an int or as a uint, or have one custom variable behave as a different custom variable. And there's reasons you need to do that, right? And there's quite a bit more to reflection, but I just wanted to show that here. That's kind of a bonus for us. So that's it. A last moment thing I want to take a look at here. Because we've extended mono behavior, we're able to use some conspicuously named methods. Start is called exactly once when we hit play. So the reason that all of our code is sitting inside the start method here is because we want it to execute exactly once. Also, update is a place where code can execute more than once. So let's see if I put a debug log inside of the update. I save, I tab back over to our application, and then I'm going to run. You can see update. All of our usual debug log statements executed at the top of this list, and then you can see that this is continuing to run, and it will run forever and ever. You can see we're up to 800 already, 900 already, and it will just continue like that until we hit play again, which ends the play mode and brings us back to edit. So the reason that you would put code inside start is to execute exactly once, and the reason you put code into update is so you can have it execute more than once. And the following projects that we'll do will take advantage of both of those as well as some other things. Let me take one more look at Unity itself. I think we've covered everything. We can see some errors are popping up here, but that's no big deal. Yeah, actually, let's take a look at the console window. So let me go ahead and play. And because I removed the update statement, we have just these many lines going in. So I want to show a few things. If we click on the log speech bubble, that's going to show us logs. If we click on the warnings, that's going to show us any warnings. We currently have none. So you can choose if you want to see the logs and if you don't want to. Right? Depending on, maybe you're only focused on fixing a warning, you'd only want to view that. Maybe you don't care about the warnings, you only want to focus on the log statements. If the code had run into an error, which we haven't seen yet, you can highlight that, error on pause, and when error happens, you will pause. Right? You can have every time you hit play, you want to have this console window clear out so that you know that the statements you're seeing in the console window are always fresh and from the latest play. By default, I have clear on play selected. So what the collapse will do is it will show you how many times 1, 1, 1, 1, 1 did this line get logged to the console window. That can be useful in more complex projects when you have a very busy console window with lots of those update type statements. By clicking console, by clicking collapse, it will collapse each of those statements so you're not seeing quite so much traffic in that window. And then clear, we can use either while the app is playing or when it's stopped, and it just clears the end window again so that when I stop and start, we can see the text pops up again. So we've taken a look at, in this video, primitive data types, a general look at how each of these projects is going to be set up, how we look at the code, how we pop back into Unity, how we play and pause. We've learned a little bit about debug.log as well as the console window. So that's it. Thank you.